Good afternoon. My name is Nader Vadiee. I'm a STEM educator. I have been STEM educator for past 30 years, focusing on students with underserved or underrepresented communities and students. And last 20 years, I have been working with Native American communities and Native American colleges. And I like to thank Office of Research and Engineering, Dr. Staffin and his team for inviting me to sharing my story with you. So, before I get into some innovative ways that we have found to bring a STEM education to Native American students and colleges, high schools, middle schools, I'd like to give you a little bit of background about the population that I have been serving past 20 years. I'm a faculty with a small college in New Mexico, Southwestern Indian Polytechnic Institute. It's the only federally funded community college for Native Americans. There are two universities, Haskell and SIPI, Southwestern Indian Polytechnic Institute, that are under the Department of Interior. So we are a federal government funded, a federal office. And that adds to its challenges when it comes to all these policies, rules of travel or purchasing that I have been working with in a government setting. So it's a national community college. There are 36 community colleges, tribal community colleges, that are affiliated with the specific tribe. We are the only one that is national. Our students represent more than 80 different tribes from Alaska all the way to New Mexico. It's federally funded, of course, and it's open enrollment. As long as you are a member of a federally recognized tribe, you are welcome. So there's no ACT or SAT. It's an open enrollment. It's a free room and board. The students pay a small fee of about maybe $300 per trimester. We are a trimester system. And the average age of the students is about 24, 25, coming from small communities. Single moms, single dads, some of them with children. And then 70% of my students enter the college, our college, with a math and science proficiency level of 8th grade or 9th grade. They have a high school degree, but they're not ready for post-secondary college. Just imagine lifting them to a level of Calculus 1. That's the math that I need for my program, engineering program, the first math course. Most of them are first-generation college students, and there are strong ties with communities. They are MCs, they are tribal leaders, they have roles in their families and their communities. And going to school, going to STEM degrees is not very revered. If you finish your high school, you're supposed to help your family. Help your family with the farm, with the harvesting, with the family business. So that's the priority that as a grown-up or an adult you have towards your family or your community. So this is a little bit of background of the population that I serve. And then I'd like to share with you, and then past 20 years, I have tuned and tweaked this system to serve the population that I'm serving. And one size does not fit all. They are called underrepresented, underserved, but Native American, Hispanics, or African Americans they have their own socioeconomic or cultural aspects. So the system has been tweaked, and then we have come up with some very good innovative ways of from outreach and recruitment all the way to graduation, transfer, and job placement. So our vision is how do we work with others, partnerships. So we always have been looking for fair and equitable win-win partnerships with the mainstream colleges. The second one is a capacity building on tribal colleges, universities. Sharing resources among tribal colleges. Not every one of us, 36 tribal colleges, are the same. They have our own, each one has their own strengths. And the numbers does not justify for each of us to have an engineering program. The number does not justify, the resources does not justify. So we need to work together. We need to build bridges between the tribal colleges. And of course, the last one is sustainable programs. So we need to make sure that we have a plan, a vision, and we don't sway with the wave of funding, federal government funding. We need to establish sustainable programs. So, starting from the innovative outreach and recruitment ways that we have used robotics, space exploration, autonomous vehicles, drones, rovers, rockets, as a means in order to get the students interested in science, technology, engineering, and mathematics. So one of the projects that we have done on our campus is building a Mars yard, an indoor Mars yard funded by NASA Office of Education. And then it's a Mars train with rovers placed on the Mars, and then developing a curriculum. So our feeder high schools, partner high schools, can log on to our Mars yard, can RSVP during the calculus or physics class, and they can log on to the Mars yard, navigate the rovers, and download the sensory information and upload codes to impact the behavior of the robots. But what is most important is how we teach them the relevance of math, science, physics, chemistry. So this is not the goal. That's just a tool to get the students to move forward. So we have built one of the programs that we have is Robotic Kids that we built in our college, and we share it with our 4 feeder high schools. Last year, we built 150 of this Roadrunner series, and we shipped it to our high schools. My students, senior students, Native Americans, went to these high schools, worked as a teaching assistants and co-teaching with the teachers. What we are going to do this year, we are not going to ship the kits anymore. We are going to buy them a 3D printer. And then we share them with the Excel files, CAD files. So they print the parts on their home schools and they assemble it. We provide the manual and the curriculum. So we are introducing them to a robotics technology and 3D printing at the same time. So we have a program here that we actually build this and we ship it to our partner high schools. So another project that we started just to get these kids interested, we call it Navajo Car, with the help from a company, IF, in New Mexico. And these are the robots that respond to Native American language, voice commands. We started the first one with the Navajo or Diné language that takes command in Diné, and also now we are expanding it to other Native American languages. Just to get the students interested in also in their own language and culture, and it generated a lot of excitement that they can actually communicate with a robot. It takes commands, and it takes a sequence of commands as a program in their native language. So this is they are the reporters from the Navajo Times. They came to our college to actually test the NAVCAR. So this is our latest product. Is a 6-wheel rover. We call it Rovers. This is our recruitment outreach robot that it rolls into the classrooms. It has an Amazon Alexa capability. So the kids start asking questions about college, admission, tuition, other things, or any other subject. And then we also made the Alexa to interface with the motor actions through the robot operating system. So once they start engaging with the rover, they also can command it to do some rover actions. This is the coolest way that you can get their attention rather than handing out brochures that they keep it for a couple of minutes and they throw it out. So we built 5 of these for 5 tribal colleges, and they are our recruitment officers. They walk in the classroom and they interact with their students. And then, hopefully with the help from DoD and NASA, we like to manufacture more of these for all 36 colleges. These rovers, recruitment and outreach vehicle. So that's interesting that this is the Rovers that Johnson Space, JPL built, NASA. And then it was not ready to share with us. We built our own rover with 1/10 of the budget of NASA. I'm sure we built it with 1/10 of the budget, maybe more, 100 of the budget of NASA. We are a small school, poor school. We are funded by federal government. 98% of our budget goes to cafeteria, salaries, and dorms. With 2%, there's no way that you can do things like this. So we are heavily dependent on federal government or private agencies grants. And DoD has been very nice to us. We received 3 times of instrumentation grant, $500,000 each time. And also the latest one, we are a partner with the DoD Center of Excellence in autonomous vehicles. So, and then this is our Mars yard. This is the poster for our Mars. We call it IC Mars, but actually it stands for Intelligent Cooperative Multi-Agent Robotic Systems. But just to make it cool for kids, we call it IC Mars. And this is the name of the project that we have. So this is a view of our indoor Mars yard with the backdrop of the Gale crater on Mars. So we use this laboratory to teach civil engineering, mechanical engineering, electrical engineering, computer science, geology, everything. So it's just a place that we can engage our students. And soon it will be ready for anyone across the United States to RSVP and log on to our Mars yard and then do their activities. The unit of activity is called a mission. So we have mission 1, mission 2, mission 3, from simple missions to more complicated missions. So another way that we reach out to our high schools is through virtual reality. A lot of these high schools don't have money to travel, to come to our school. We go to them and we give them a tour of our laboratories through the virtual reality goggles. And these goggles are made at SIPI by our students. So another creative way that we do our outreach is using the augmented reality sandbox that we use it for the students to learn about the geometry, trigonometry, using an augmented reality sandbox. So once they are in, we match them with teams. We call it vertically integrated project. So it's a high school kids, CP seniors, UNM seniors, graduate students, postdocs, faculty. In a pyramid, they work together. And there is a dynamic of learning and teaching going on between layers. So from the moment that they step in my college, they are matched with a team. and they grow through this pyramid, and they interact with the. My students come from small communities. University of New Mexico, next to us, is a black hole for them. So you need to make the transition smooth for them. So I'm hiring back my former students to come to SIPI as teaching assistants and research assistants. This makes the transfer smoother for them. They have a friend there, they have a buddy there. So that's what I mean by closing the circuit. So these are the 5 tribal colleges this summer. I hosted them on my college, and each team, they built a 3D printable drone and a 3D printable rover, each one of them. There are 17 students from 5 tribal colleges, and they took this back home to use it for their own outreach and recruitment. So this is the graduating class just this summer that they came to SIPI, and we hosted them. So one of our visions is that we need to treat all these different ways of representing the world, representations, world model the same way. Naturally, we do a lot of emphasis on mathematics, analytics, but we need to put enough emphasis on other aspects of the world modeling, especially computational. That's the future. So we do a lot of computational tools that the students learn to do, because we are seeing a paradigm shift in engineering education, not just for tribal colleges, because of all these changes in environment, energy, new materials, small materials, computational tools, access to information, and communication. Engineering education is going through a paradigm shift because of all these tools that we have. And then we need to bring those into our communities. So these are some of the innovation programs that we have had in our students. We are a 2-year community college with a set curriculum. We are a teaching school. So I have found ways through 4 courses to bring in cutting-edge research through the design project, a special topics course, internships, and intro to engineering. So these are my 4 courses on the book that I use to bring in new and cutting edge to a 2-year college. Okay, so, and then of course, research is not our goal. We are a teaching school. Research is a destination, but what we focus is on the journey. The journey is important. Understanding the relevance of math, physics, social sciences, computational tools to engineering. My students come to SIPI and they start with the math 98. So they have to go to 98, 99, 100, 120, 123, 150 before even I see them. They lose interest. They're disenchanted. They leave a school. Our published rate of retention is 20%, less than 20%, and graduation rate. It's a rusty, leaky pipeline. So if I can only plug the holes, I have increased a lot of students rather than focusing on the recruitment. So this is what we are doing. We are just repairing this pipeline from community all the way to graduate school, to jobs, and to community background. So these are the 7 pillars of research experience: soft skills, exposure to careers, mentoring and tutoring, learning new and cutting-edge research and developing the field, cross-disciplinary team project, and community-based projects. So these are our 7 pillars of research experience for a teaching school, a community. So we do a lot of problem-based learning. This was a biofield project that we did, and we won to the national competition, and we won the championship. So we encourage the students to bring problems from their chapter houses, from communities, a water reservoir, a farm, an irrigation channel, and then make it a class project in order to connect with the communities. So this is the course that I offer it every semester. Upfront, no prerequisite. Come on in. And then, past 10 years, 600 students have gone through this course. And that's my recruitment ground. They expose them to engineering and then tell them what it takes to become a good engineer. So we are building capacity, 3D printing, advanced manufacturing laboratory. And this is our Mars yard, and this is a visit that Dr. Staffin and his team graciously spent a day in our college, so they can testify to what we are doing there. They got a good tour, and this is a picture that I have from their visit. And also, I have a visit by Miss Evelyn Kent from, again, DODF. And then we have another grant, which is a part of a Center of Excellence, working with North Carolina and UTSA. We are part of a consortium with North Carolina and UTSA. Hispanic serving, African American, and the Trevor College, which is a beautiful partnership. So these are my happy faces that they graduated from 5 different colleges this summer. And they are showing off their certificates. We are sharing resources with other Trevor colleges. That's the name of the game. And then we are closing the circle. He graduated from SIPI, got his bachelor, and bring him back to teach the new students. I noticed that I'm spending a lot of money and investment in the first 2 years. The real challenge is the next 2 years that they move on to a 4-year school. There's a lot of life events that my students get distracted before they drop off from high school. So now I'm focusing on the next 2 years in order to make sure that they graduate from a bachelor. So, and then we include all generations. This is my NASA Swarmathon team, and Grandma Begay traveled all the way from Arizona to come to our practice in order to cheer her son, who was part of this NASA Swarmathon team. So you have to work with the community. And in this culture, if you make grandma happy, you are set. Make sure you make grandma happy and you have the blessing from grandma. So this is also another way that we have the community support for our students. And these are my graduates. 30 students have graduated, moved on to 4-year schools, and I'm still in contact with them. Happy faces. I'm starting seeing their children coming back. That's how it works. It's not brochures, it's not TV ads. It's a smoke signal. It has to trickle down to the community. They graduate, they send their sisters, brothers, and if I stay longer, I will start seeing the grandchildren of my students as my students. But I better get out of here. 40 years is enough. So these are some of the awards and recognitions that we got. The latest one, we received the Toyota STEM Award, which was a grand prize. So next month, Toyota will ship a brand new Toyota minivan with $5,000 to recognize our program. We have the largest pre-engineering program among the tribal colleges, 75 students. This is huge for a Native American community. So we received the Global Mind Award, NASA Swarmathon Grand Prize. That was the biggest boost in morale of my students. So anyway, we have some innovations in recruitment, outreach, placement, retention, and graduation. And I will be glad to share with you. And also, we are open for business. We can get orders to build your rovers and drones for outreach. Just let us know. Thank you.